Hello students. This tutorial will address and review ionic and net ionic equations. In honors chemistry, we primarily dealt with our full equations. Ionic equations show us how the species really exist. Are they existing as molecules, as neutral compounds, as solids, or are they existing as soluble ions or soluble molecules in aqueous solution? Net ionic equations are free of spectator ions. So as far as advanced chemistry, this is really all that we're concerned about. What is actually undergoing a chemical transformation? What is being altered from reactant to product? What truly is driving the reactants to form products? So, to dig right in, these are some of the examples that I will use in our review session and, of course, here now. So let's dig right in. Let's get the full equation first. Calcium metal is reacted with water. Unless told the exact experimental conditions, we definitely predict this is at room temperature and pressure. So calcium, solid, and water, liquid. Element plus compound, this will be a single replacement. Calcium, being an alkaline earth metal, is definitely reactive enough to replace hydrogen. In fact, we are going to create the metal hydroxide, in this case, plus 2 minus 1, there's our formula, and liberate hydrogen. Hydrogen, gas, and calcium hydroxide. Now, hydroxides are tricky, but alkaline earth, we're safe to call aqueous. Now, this would be the full equation. Now, the ionic would be showing any species existing as ions. Now, the things that exist as ions are soluble ionic compounds that dissociate in the presence of water. Would be our strong acids. And that's it. So if it's a weak acid, it will not be shown as separate ions. If it is an insoluble ionic, of course, it will not be shown. If it is a soluble covalent, it will not be shown. For example, sucrose as separate ions, because that does not create or dissociate into separate ions. So, calcium, no, solid remains solid. Liquid, well, that remains liquid. All right, but a soluble ionic, this will be existing. Oh, I want to make sure I'm balanced, for crying out loud. So I need a 2 and a 2. This will be existing as separate ions. And remember, we have to obey the formula. And because this is satisfying this, and then hydrogen will still be existing as a gas. Now, the net ionic would be absent of any spectators. Chemical species that appear in identical form on the reactant and product side. Well, calcium is existing as a solid, neutral, elemental form. But here it's existing as an ion, aqueous. Those are not the same. So those would not be canceled, and neither would anything else. So here, the ionic and the net ionic are actually the same. This is our final equation. Now, there's also a possibility that the ionic and the net ionic all are the same. For example, potassium chlorate decomposing to give us potassium chloride and oxygen gas. Nothing here is existing in ion form. So it's not that we don't have an ionic or a net ionic, just the ionic and net ionic are all the same. Let's try this one. Solutions of nitric acid and calcium acetate are mixed. Compound plus compound. Now, there's a possibility this is double replacement. We are going to form acetic acid and calcium nitrate. All acetate compounds are soluble, all nitrate compounds are soluble. Now, we should have our kind of awareness heightened here. I want to balance it. Now the question is, does this reaction even happen? Is there a driving force? Well, with double replacement reactions will only happen if we produce water. Nope, not happening here. If we produce a gas. Not happening here. If there's a transfer of electrons, if things undergo a change of charge in the case of oxidation reduction. Not happening here. If we produce a precipitate. Not happening here. Or if we create a molecular species that will not be existing as separate ions. Well, this is ionic. This is soluble ionic. This will be existing as separate ions. But this is a weak acid. This will only be ionizing slightly. And since it's ionizing only slightly, we will not be writing it as separate ions. We'll be writing it as a molecular species. So this reaction will happen. Let's prove it. So this is the full. Let's write the ionic. So we will create 2 hydrogen ions. Remember, it's a strong acid. It will be existing as separate ions. And 2 nitrates, aqueous. This is also as separate ions, calcium, and 2 acetates. However, this will stay as acetic acid, weak acid, but this will be separate ions, plus 2NO3. So we do have spectators, calcium and the nitrate. So the net ionic is absent of spectators. What is driving this reaction to occur is the creation of our molecular acetic acid. And to just polish this up, what we should do is reduce our coefficients all to 1. That is the net ionic for that reaction. Let's see. We did this in the previous, but just to show again, aluminum metal is heated in a fluorine environment. Element plus element. Nothing exists as ions. So our full ionic and net ionic are the same. How about liquid methanol is ignited? Liquid plus gas yielding gas and gas. Nothing exists as ionic or as ions. So your full ionic and net ionic are the same. What if we do solutions of sodium sulfate and potassium hydroxide are mixed? This will create sodium hydroxide and potassium sulfate. All sodium compounds soluble, all potassium compounds soluble. And I'm going to need a 2 and a 2 to balance. Okay, have we created water? No. Have we created a gas? No. A precipitate? No. Anything undergoing a change of charge? No. Have we created a molecular species that does not get written of as ions in solution? No. So actually, this is a no reaction, but let me prove it. This is going to be existing as 2 sodium ions, a sulfate ion, 2 potassiums, 2 hydroxides. That will create 2 sodiums 2 hydroxides, 2 potassiums, and 1 sulfate. Sodium, spectator. Sulfate, spectator. Potassium, spectator. Hydroxide. There's no driving force here. No reaction. There's no ionic or net ionic. So this is just forming a mixture. Just a mixture. Please look at some of the sample ionic and net ionic and practice a few, and then you've got it. As always, please forward any questions my way.